Hello, everyone. My name is Jeremy Kreis, and I'm a mechanical engineer.
Hi, my name is Joe Carpenter, and I'm also a mechanical engineer.
I'm Katarina Altman. I'm a mechanical engineer too.
I'm Riley Clark, and I'm an industrial engineer.
And my name's Connor Popo, and I'm a material science and engineering.
And we are team, the Flowserve Capstone group, and today we'll be talking with you about how this semester, how we went on verifying measurements of the inlet and outlet of different cast impellers.
So a little background on Flowserve. For the past 230 years, they've been providing diverse industrial manufacturing knowledge. Flowserve creates and delivers extraordinary flow control solutions that make the world better for everyone. The current problem statement for this project goal was our team's goal is to create a tool to accurately measure inlet and outlet area specifications in a cost and effective time manner. This will allow Flowserve to verify the impeller specifications faster, which improves the efficiency of the inspection process.
Flowserve assigned our group with two tasks for project objectives. One, as Connor said, was to create a tool that would be able to measure the critical inlet and outlet dimensions of several different size impellers in the Flowserve catalog, and then also to accompany this tool to create a document that is an instruction manual explaining how this tool will be used on the different types of impellers. Our approach for this project was to use softwares like CAD and SolidWorks to 3D design different parts and head designs for our eventual final product, and then also to utilize different facilities on Penn State's campus, including the Learning Factory, to help manufacture different parts of our product. On the left here, you'll be able to see a flow chart going through our process for this project. We started, like we talked about already, with the background and approach to the Flowserve project at hand. Then we went into idea generation and brainstorming. Next, we went into the manufacturing process. And then finally, we got to the final design and deliverables, and we'll talk more about that on the next few sections.
So with the initial idea generation, we came up with about 4 ideas during our group brainstorming session. That included a volumetric measuring of the impeller vanes, the snap ring plier attachments with adjustable heads, a telescoping caliper set, and a set of lollipop go-no-go gauges. These were then compared to one another through a decision matrix, and we were prioritizing accessibility, accuracy, lean engineering, price, and the ease of use of the tool. After going through this criteria and ranking everything, the snap ring plier approach with the adjustable heads ranked the highest of the 4 options. So we went forward with this as our final design. And we used, as Joe said, 3D printing to try out different designs, different angles, different bends of the tool to see which would work best with the prototype and with the impellers. And as you can see in figure 3, we have figures 3 and figures 4, we have our beta prototype showing the 3D printed material attached to the snap ring pliers.
Going into the manufacturing process, after we decided that we were going with the snap ring pliers, we needed to move on from 3D printing prototypes to manufacturing a concrete idea out of metal. One of the members of the group were extremely lucky enough to have a family friend that owned a powdered metal plant, and the plant was Atlas Press Metals. There, they let us use their CNC plasma cutter. So we're able to use a piece of 1/8 inch steel and cut out our prototypes. We then moved on to the Penn State Learning Factory, where we used a mill to do the machining for the 3 different holes that we needed to put into it, as well as the 1/16 inlet into the center of the impeller, or not the impeller, I'm sorry, our part to make it move back and forth. So then we finally incorporated a 25-degree bend into our tool to help us access the inlet and outlet dimensions better, and prevent us from hitting that impeller hub. So yeah.
So once the manufacturing process came to an end, the group was able to divide up the last few tasks for the final deliverables. An instruction manual was created specifically for the device using a template Flowserve provided us. This document is a method of best practice to standardize the process for this tool. And on top of this, the manufactured pliers were calibrated to ensure the user can obtain measurements to the nearest 0.1 millimeters. And in figures 7 and 8, you can see those two deliverables. And finally, the team would like to acknowledge Dr. Elamini Ledihat, the team's faculty advisor, and Philip Garcia, the team's sponsor, and Atlas Press Metals for all the help throughout the project.